Hello everyone. This is a problem based on projectile motion and circular motion a bit and little bit of basics on plotting graphs on a graph paper. So we'll see how to solve this problem. Before that, let's begin with the given data in the question. Let me just go through the question once. A stone is projected from the ground with a velocity of 10 meter per second and its trajectory is drawn to an unknown scale on a graph paper. The horizontal range and the maximum height on the graph are 1 meter and 0.25 meter respectively. The graph paper is glued on a horizontal tabletop. If an insect moves along the trajectory on the graph paper with a uniform speed of 1 centimeter per second, what should be the modulus of its maximum acceleration b is our question. Given acceleration due to gravity is 10 meter per second square. So going through the question, I hope you would have got some basic idea that like data given here is by just looking at the information, h maximum on the graph sheet is 0.25 meters and range on the graph sheet is 1 meter it seems. So if this is happening on the graph sheet, so basically we are plotting a graph sheet. Let me consider this is a graph sheet. This is our x-axis and y-axis. So x-axis, let me say horizontal, y-axis obviously vertical. So by considering this is a graph sheet which we already have, and we have plotted this projectile motion data onto this graph sheet. So first let's visualize how projectile motion is happening in this situation. So 10 meter per second is the speed with which we are throwing at some unknown angle. We don't know what it is. So if g is 10 meter per second square acting downwards, then we know that this particle will follow parabolic path and it will hit somewhere here. So if on the graph sheet, if you are getting this kind of info, like from here, if I start having this projectile motion like this, from here to this point, this range is 1 meter it seems. And from here to this one, not to scale, just randomly writing 0.25 meters. Okay. Now we are writing this graph for the given real life situation, which is g being 10 meter per second square. We are throwing at 10 meter per second with respect to horizontal. On the graph, if h maximum and range are related like this, which is range is 4 times of h maximum, even in real life situation, this is the same story should be happening. Okay, so by using this information, we can write v naught squared sine 2 theta by g, the formula for range, 4 times of v naught squared sine squared theta by 2g for h maximum, 4 times of h maximum, simplifying 2 times. So we have 2 sine theta cos theta being equal to 2 sine squared theta. Simplifying it further, tan theta being equal to 1. Tan theta being equal to 1. So theta from 0 to 90 degree, we know it is 45 degree or pi by 4. You are very much familiar with this. So dear students, meaning in the real life situation, theta here is 45 degrees. We know that for theta being 45 degree, range is maximum, and that range we can easily predict in real life situation. In real life situation, range is given by, or maximum is given by v naught squared by g, using that information here, like 10 squared 100 by g given to be 10. So maximum range which we will see is going to be 10 meters. But on the graph paper, we are having like 1 meter. So basically by comparing this one with what we have on the graph sheet, we can easily predict that and compare the scaling that 10 centimeter 10 centimeter on the graph sheet should be equal to 1 meter of horizontal length. So if we use this kind of scaling, then we have like R maximum is 10 meters. If R maximum is 10 meters, what we see is 10 meters. But if you want to plot it on the graph paper, so 1 meter is 10 centimeters. So 10 meters is 100 centimeter. 100 centimeter is 1 meter. That's what we have on the x-axis. Along y-axis, we have h maximum is 0.25 meter. So basically, we can get from this given data h maximum value as well using our formulation. H maximum value is substituting in this formula. We can get h maximum equals v naught squared sine 45 squared by 2g, right? So it is 100 sine 45 1 by root 2 squared 1 by 2 20. So just simplifying this one, it is going to be 2.5 meters. What we see is 2.5 meter is the maximum height, but what we know that 1 meter 1 meter is equal to 10 centimeter on the graph paper, which means 2.5 meters is equal to 0.25 meters on the graph paper. So everything is now set. We know what is that scaling also. Along horizontal and vertical, we are using 10 centimeter on the graph paper as 1 meter of the given data or experimental data. So knowing this, now we know that the story goes like an insect will start moving on this particular trajectory. It is given it is moving at 1 centimeter per second. Just imagine this, an insect is running on this trajectory by covering 1 centimeter per second. So as you know that if it is maintaining same speed, there is no tangential acceleration. And these are the concepts with respect to your circular motion knowledge. So if a body is moving on a trajectory, we can think of its tangential acceleration as well as radial acceleration, radial or centripetal acceleration. Okay. So here, since its speed is same, so we can say tangential acceleration to 0. So radial acceleration is non-zero because it is changing its velocity vector direction. So using that information, we can even predict the radius of curvature. Radius of curvature is given by v squared by like acceleration. This is your understanding with respect to circular motion here. Now, if we want like maximum acceleration, if the insect is moving on this trajectory, it will have maximum acceleration wherever there is minimum radius of curvature. As we can see from this particular graph, if insect is moving on this particular trajectory, wherever the radius of curvature is minimum, there the acceleration is more, right? So we can easily pinpoint that at this location radius of curvature will be minimum. So meaning at that point there should be like larger rotation for the velocity vector direction. So since the direction should change, so there it needs maximum acceleration. And remember, there is no tangential acceleration. Whatever the radial acceleration we'll find, that would be its actual acceleration. Okay. So let's find out first what would be the radius of curvature in the normal situation. Normal situation meaning like real life situation here at this point. So we know that at the topmost point, range can be easily found. We know that g would be acting downwards. So using this data, we have, suppose if you are throwing a projectile at certain angle theta being 45 degrees, at the topmost point its velocity component would be 10 cos 45 horizontal component. Only that velocity will be surviving there. So 10 cos 45 by g, simplifying that, it is going to be 100 cos 45 1 by root 2 squared. So it becomes 2 in the denominator. G is 10. So range is going to be, of course, 5 meters. Dear students, 5 meters is the radius of curvature what we see in actual life, meaning experiment. But we are considering the same radius of curvature on the graph sheet. On the graph sheet, definitely it is going to be scaled down, right? We already have this information that 1 meter meaning 10 centimeter. So going on the same lines, if we have 5 meters, it is going to be 50 centimeters on the graph sheet. On the graph sheet. So this would be the radius of curvature on the graph sheet. On the graph sheet, we got 50 centimeters. So in SI system, it is zero point 0.5 meter is the radius of curvature. So using that, now insect will be traveling with some velocity, let's say u squared by that radius of curvature. That would be the acceleration we are thinking of for insect. So it's given that it is moving with 1 centimeter per second, right? So it is 1 centimeter per second squared by radius of curvature zero point 0.5, and we'll get the maximum acceleration. Here we are getting maximum acceleration because we are using a specific radius of curvature which is going to be the minimum. Okay, so since it is minimum radius of curvature, we are computing maximum acceleration. Okay, so it is going to be 2 into 10 power minus 4 meter per second square. So this would be the solution for our given question. I hope you have understood, and please try once again. And if you have any doubts or something, feel free to comment. Thank you.